Well, hello and welcome everyone to our 6th episode in AgriProve's webinar series on how to grow topsoils. I'd like to begin by acknowledging the traditional custodians on the land which we're gathered wherever we're watching this webinar and pay our respects to elders past, present and emerging. My name is Matthew Warnkin. I'm Managing Director of AgriProve. AgriProve is a specialist soil carbon solutions company focused on enabling participation opportunities for farmers in carbon markets and other environmental markets, creating the potential to access additional revenues. We're hosting this 7-part series. I'm very fortunate to have Declan McDonald, Principal Soil Scientist with Regen Soils, here to help unpack the journey on how to improve soil health and grow soil carbon. Declan is a certified professional soil scientist with over 30 years experience in soils and agriculture, spanning both private and public sectors. So very well placed to guide us on this journey into growing soil carbon. And so far, over the past 5 sessions, we've traversed a huge amount of territory. How soils work, how plants grow, focusing on the organic matter as a cornerstone of soil health and sustainable production. A deep dive into soil biology, looking at mineral management and the role of macro and micro elements. And the last episode was managing fertility as how to build soil carbon. And there, standouts for me is the fact that we can't control soil carbon as easy as we can control a bag of urea. So we really do need to understand soil function more and spend that time on that management of soil, because it is an ongoing activity. The importance in terms of changing those management practices, that there are no sudden jolts. And then a unique insight into not only conceptual models of soil, but how Declan conducts his banking affairs with labile resistant and recalcitrant soil carbon pools. But that labile pool being that the cash, the sort of more the credit card activities being more that humus middle pool, and that lump of gold that's tied up with your bank manager being the recalcitrant soil carbon pools. And Declan, you can give us more of that insight later on today if I've missed anything there. But the importance of particulate organic carbon, that labile pool, which seem to be low in cropping systems, but does seem to respond very quickly to management practices. For those who are looking at a recording, there was a great Q&A in that episode number 5, where we did a lot of follow-up, so well worth going back and delving in there. This webinar is on management practices to grow soil carbon. This is where we really start to look at practical ways to implement changes on farm and how we actually go about growing soil carbon. Before we start, as usual, some housekeeping. We are recording these webinars. They are available on our website, so you can catch up or go over past material if you do miss a session. We'll be running for around an hour with Declan on for about 40 minutes and having questions at the end. We're also streaming on YouTube Live. Now there's a chat pane on YouTube Live there for questions and comments. And also please use the Q&A for questions and any comments if you're tuning in through Zoom. Feel free to also use the chat function. Without any further ado, webinar number 6, hand over to Declan. Thank you very much, Declan. Looking forward very much to this episode in our webinar series. Thanks.
Thanks, Matthew. Okay, so hopefully you've got my presentation screen on display. So yes, is that right, Matthew?
We've got you loud and clear, but not your presentation.
Not my presentation.
No, so
have a look at that. Does that change anything?
No. We did have this ironed out beforehand, and we'd also developed some immediate fallbacks. But do you want to try one more time, just in terms of going through that share screen function, Declan?
Yes, okay. Okay, so you can see me okay. I'm going to try again, share that screen.
Yep, so we've got it now as your screen, but I think you need to go to presentation view, and there we've got it. Brilliant.
View, okay. Thanks for your patience, everybody, and sorry about, I'm not sure what went to happen there. Okay, so we really want to get practical now and talk about management practices that we want to employ, change, or adjust to grow soil carbon. And just by way of kind of catching up, when we're talking about sequestering soil carbon, it's, you know, in its most simple terms, we're talking about a carbon balance. So how much carbon is going into the system versus how much carbon is leaving the system. And the lost pathways for carbon is principally as carbon dioxide, and this is respired carbon. So I shouldn't need to make the point, but I think I do need to make the point that the lost pathway of carbon is driven by soil microbes primarily. You know, soil decomposition, as we've talked about before, decomposition in soil, I should say, is really, you know, the most important function, because it's what drives nutrient cycling. And we've shown this little graph a few times, which shows that, you know, post-clearing, we've lost about 50% of our soil organic carbon. And in this particular example here, where we've got a figure on the y-axis of 70 tons per hectare of organic carbon, what the graph is showing us is that we're down to 50% of that total. So we're gone from about a 5% organic carbon soil to a 2.5% organic carbon soil. And of course, the challenge is that increasing soil organic carbon really requires some commitment. And we've talked quite a bit about that in previous webinars. And as a general rule of thumb, we talk about increasing soil carbon by 1% requires about 50 tons of dry matter to be put back into the soil. Now, that's a pretty rough figure, and there's so many dependencies that hang off of that, which I won't talk about now. But it's there really to highlight the point that it really does take some commitment. And of course, that's not going to happen suddenly. So we're looking at change over the long term. And it's important to note also that sequestered carbon, what we're trying to do is we're trying to build the humus pool in particular. As we showed last week, you know, the short-term rise in sequestered carbon is primarily in the particulate or labile pool, which is wonderful. That's, if you like, the early stage of humus development. But ultimately, when we're looking at change over the long term, it's humus carbon that we want to see change in. So what can we do to sequester soil organic carbon? Now, I guess so much of what I'm presenting here, I'm presenting in the context of regenerating soils and regenerative agriculture. And so there's these 5 broad principles of regenerative agriculture that we're working with, and I've selected this graphic from the Lower Blackwood Catchment's website, but it's a similar graphic to what I've used previously for other webinars. The principles are, first and foremost, keep the soil covered. You know, it's such a it's a no-brainer. Actually, most of these are no-brainers when we think about it. But keeping soil covered is so critical in terms of protecting the workers in the soil and making sure that the very top layers of soil, the most fertile and active layer in the soil, is allowed to be just that, fertile and active. And if we bare the soil, we're having a disproportionate impact on the productivity of our soil. So we really want to keep soil covered and keep it covered year round. And ideally, the second principle is we want to maintain living roots year round as well, because we want to have that carbon constantly going into the soil. We don't want to have a feast and famine. And that's the problem that we have when we have, say, a 6-month fallow, or even where we're applying mineral fertilizers, you know, at the start of the growing season. We're we're applying a feast of nutrients, usually more than the soil is able to digest at one time. And then we're asking the soil to survive on that feed for the entire year. But of course, nature does not work like that. If we can feed the soil every day across the year, we're going to be supporting continuous soil function. Part and parcel of that is minimizing soil disturbance. So as we've discussed, any kind of soil disturbance, be it the compaction from an animal's hoof, a tractor, cultivation, anything like that is going to alter the soil environment in a small way or in a major way. And the soil community has to recover from that, and that takes time. And whilst that's happening, normal soil function is going to be interrupted. Integrating livestock is really important. Livestock gives us the opportunity, particularly on grazing land, of course, to really manage the pastures in a way that is going to optimize the input of organic material into the soil and really promote high levels of biological activity and promote high levels of production. And the fifth principle is about maximizing diversity. And we talk about crop diversity, and we talked a lot about that in earlier modules about the importance of diverse root architectures and the diversity of different compounds that each of those different root types and plant types puts into the soil. And that promotes below ground diversity in the form of a broad, resilient and stable soil population. So we talked a bit about where sequestered carbon comes from. And I'm not sure if we talked too much about the myth of nitrogen fertilizing, but the story that, that I was educated to and unfortunately that I propagated for many years was that we grow organic carbon basically by growing big crops and growing lots of biomass and big roots and all that kind of thing, and that's what restores our soil organic matter, our soil organic carbon. And we do that by using fertilizers to grow big crops. And certainly the fertilizers grow big crops, but what we're understanding now, particularly with nitrogen, is the more nitrogen we put on, the more we're burning up the organic matter that's in the soil. Organic matter preservation in the soil, we've talked a little bit about, is based on a few things, but one of the really important aspects of soil organic matter preservation is the carbon to nitrogen ratio in the soil. And nature is structured such that the carbon to nitrogen ratio is optimally around 12 to 1, 12 parts of carbon to 1 part of nitrogen, 12, 15 to 1, something around there. If we tilt the carbon to nitrogen ratio below 12, we're promoting the degradation of the carbon, because we suddenly have a heap of nitrogen that's available. Bacteria in particular will respond very strongly to that, and they gobble up the soil carbon. And in fact, a lot of this work came out of the moral plots in the United States, which are, I think, the oldest ongoing research plots in the United States. And they showed that after 40 to 50 years of synthetic fertilizer addition, soil organic carbon declined despite massive residue incorporation. And the similar story has been repeated across geographic regions, soils and tillage practices. And in fact, the same has been shown here in Victoria under no-till. Many of those systems are at best maintaining soil carbon levels, but many no-till systems, carbon is still slowly declining under those systems. And as I said, mineral N enhances microbial degradation of plant residue, soil carbon, and consequently reduces the supply of organic nitrogen, which we've talked about before as well. This is a really important paper that came out only last year, and it's a review paper, or in that it drew on a lot of recent research that showed that really large proportion of total soil carbon is contributed by microbial detritus. So where we once thought that soil carbon sequestration was a product of plant biomass, this paper is showing us that a substantial proportion, almost 2/3, is a product of microbial detritus. So that means we have to grow up really high levels of soil livestock to sequester carbon. The same research showed that total soil nitrogen and carbon were more important than rainfall acidity and clay content to soil carbon sequestration, and that nutrient addition to fresh organic matter, and we're talking here about high carbon to nitrogen ratio material like hay and stubble, can increase soil carbon sequestration really substantially. And it can also reduce mineralization of pre-existing soil organic matter. So that means if we're adding nutrients to support the degradation of this fresh organic matter, it's helping to preserve the organic matter that's already in the soil. So this emphasizes the need to think about soil agronomy rather than focus on plant agronomy. And modern agriculture has very much grown up around what the plant needs, NPK, give the plant what it needs, grow a big plant, etc. But we're talking here about maintaining a whole system and growing soil health at the same time as growing productive and profitable crops. Now, we talked briefly about this, but just wanted to reinforce the point as well that, you know, this is about soil carbon storage capacity being you know, a product of continuous inputs of organic matter. And even in discussing this diagram before, you know, the focus is on the continuing input of organic matter. What we're not saying, but what we need to say, is that the continuous input of organic matter is driving those microbial populations, and that is what's laying down sequestered carbon. So it's really about feeding the soil and continuing to feed the soil so that we get those microbial populations building and sequestering. So it begs the question, what should I be doing? And I've kind of divided the answer up to this very simply in two ways. One is what I've called fixing it. And I include under that things like you know, drainage management, ripping, efforts to keep water on the farm, tools like soil key, etc. And the other part of it is I've called helping it. And I've included under this heading grazing management, compost and subsoil manuring, intercropping / cover cropping, and trees. So the fixing it is, you know, traditionally I think what we have, you know, been encouraged to do, which is to kind of get out there with our powerful machines and, you know, if the soil is a bit sluggish or drainage is a bit of an issue, or we think we've got a bit of compaction, well, you know, ripping it all up, it kind of feels good. It feels like we're really doing something. And, you know, there's nothing more pleasurable in my experience than preparing a nice seedbed. But I think we tended to overdo that by getting in and, you know, with this kind of digging up thinking that really puts ourselves in the forefront of the frame that says, you know, I am going to fix this soil, and I'm going to fix it by pulverizing it into submission, which is what we've ended up doing in a lot of situations and continue to do. Keeping water on the farm is very much about altering the landscape as well with steel. And soil key, whilst you know, I'm a big fan of soil key is still getting in, and so none of these things are bad. It's just that they have their place, and I think our use of some of these tools has been less than strategic. We'll talk a little bit more about these going through. The helping it is a little bit more, dare I refer to it as a more kind of humble approach, or a respectful approach, where we're saying with these kinds of approaches, we're working more with nature and encouraging nature to, you know, express its fertility and its potential through good management and through thinking about feeding soil function. So let's talk a little bit more about each of these as we go through. So when we talk about, ripping, there's a lot of interest these days in the yeoman's plough, and I got to say I am a big fan of the yeoman's plough. I think it's a fantastic tool. Generally narrow tines, low level of disturbance, doesn't mix subsoil with topsoil, and does a really good job breaking up subsurface compaction. The over-enthusiastic use of things like yeoman's ploughs that I've seen relate to, and in fact, I was on a farm just last week where there was a plan to rip the whole farm because there's issues with drainage on this farm. But when we talked it through, we identified that the reason that there's a problem on this farm with drainage is because of sodic subsoils, and if we rip too deeply into sodic subsoils, we're likely to not only have little long-term gain, but we really run the risk of creating serious problems for ourselves, particularly on sloping grounds. We can facilitate tunnel erosion at worst, or really achieve very little at best. So in a situation like that, my advice was to really reduce the intended depth of ripping, but rip into the top maybe 2 inches of this sodic subsoil. And if we can incorporate lime, and one participant in this particular farm walk had the intention of dribbling calcipril down behind the tine to drop lime into this acidic sodic subsoil, because as we've discussed in previous webinars, lime, calcium in particular, is a really good flocculating agent. And if we can use that lime to help displace some of the sodium in the sodic soil and provide some measure of flocculation, some measure of soil structural improvement, then we open the door for plant roots to go in, organic matter to be sequestered at greater depths in the soil, and gradually increase the depth of soil in that way. So that might mean that we go in every year or second year and just cultivate a little bit deeper each time. And in this way, we can rehabilitate and solve the problem on these soils. But going in blindly or without a kind of backup plan, the backup plan being application of calcium, getting deep roots down into the ripped lines and retaining the opening that we've just done, the chances are it will revert back to previous in a short period of time. Now, I want to talk briefly about keeping water on farms, and this is with a nod to Peter Andrews' natural sequence farming, which many of you are probably familiar with, and also I just want to briefly mention Keyline Design, which is Mr. Yeomans of the plough fame, his water for every farm approach. So the issues about keeping water on farms is, we've got eroded gullies and tunnel erosion and across so many of our landscapes. We've lost our billabong system, which was the mechanism which held water up in our landscapes and allowed longer rehydration, or rather prevented dehydration of the landscape. But because we didn't like these things, and because we saw them robbing us of potentially productive land, we straightened out the systems, we declogged the billabongs, and we drained the landscape. We have dehydrated the landscape, and that is not something that we can afford to do in a brittle environment with distinct lengthy dry seasons. So some of the solutions of better management of water on farms is getting stock out of waterways, of course, thinking about where it's safe to flood. So using Peter Andrews' concept of leaky weirs, the idea there is that we allow rivers to flood onto floodplains to not only deposit fertile sediments, if that's the case, but also to help rehydrate landscapes. Leaky weirs are very much a part and parcel of that. Planting and fencing waterways is part of getting stock out. And are we adequately addressing erosion risk associated with water movement on farms? And this is a graphic which I borrowed from Dobes, which illustrates the benefit of creating these leaky weir type structures and the benefits associated with raising local water table, maintaining water in the landscape, and maintaining that hydration, which used in conjunction with deep-rooted perennials is going to significantly extend our growing seasons. Permaculture talks very much about design, and what we're trying to do with our design is to support, natural self-organization that nature is trying to do. So we want to design systems that mimic nature or work with nature to meet our objectives. And permaculture has developed this concept of zones on a farm. Agroecological principles similarly aim to work with the natural flow of the land. And there's various disciplines such as landscape function that have been developed to monitor ground cover in particular and plant diversity. And P.A. Yeoman's keyline system, and this here is an example of the placement of dams at strategic locations across the landscape and the distribution of water from ridge lines into dams, and the use of contour ploughing and contour planting, etc., to arrest the movement of water down slope, again, thereby slowing the dehydration of our landscapes. Most of you are probably familiar with the soil key machine, and the beauty of the soil key is that it is allowing an oversowing of a pasture with localized disturbance, which effectively is a localized kind of green manuring of what's there, with sowing in of annual or perennial plants, but frequently it's annual plants which produce high biomass in a short period of time. And again, I've mentioned this before, but I think the spectacular improvement that we saw on Niels Olsen's farm, which resulted in him being the first farm to be paid for carbon credits, so much of that is most likely attributable to increased microbial function because of the way that his farm is now being managed. And these are a couple of measures that have been taken. West Gippsland CMA ran a trial looking at the effect of the soil key, and these are just a couple of bunches of data that I pulled out of that report, just to show that the soil key, has indeed increased dry matter, increased the ME of pastures, and in fact, by most measures, the soil key improved output. That doesn't mean that you have to have a soil key to get some of the benefits that we're seeing on this farm, but it's quite an elegant machine to promote rapid improvement in soil condition. Now, the other way, and now we're moving into the helping it realm here, and first amongst these really is grazing management. And from all I've seen and learned and observed and listened to on pastures across really quite a breadth of environments in Australia, I'm convinced that we need a new system for what are really brittle environments. And the vast majority of agroecological zones in southeastern Australia in particular are brittle environments. And a brittle environment is really defined by extended dry periods. And we generally have a dominant wet season in Australia. We have to go, well, actually, there's small coastal areas might have reasonable rainfall year round, but most of the time we're dealing with extended dry seasons. Now, the kind of grazing management system that we have really has been imported from the Northern Hemisphere, where water was seldom limiting, and organic matter levels are really high in those soils, and so they're forgiving of set stocking and to a degree overgrazing. But when we have overgrazing in a situation where we have an extended dry period and the pastures have got no chance of recovery because there's no rain, this is where we see really severe problems with loss of ground cover, erosion, loss of fertility, etc., etc. So holistic grazing management, I think, offers us a really significant and beneficial alternative to the models that have developed in Australia, which are very much focused around animal productivity and are less focused on soil health. You know, that thing we talked about earlier, soil agronomy versus pasture agronomy. A critical element in grazing on brittle environments is recovery times. And recovery is all about allowing plants to grow big enough and allowing litter to be deposited in sufficient quantity on the surface of the soil to protect the soil between grazings. Stock density is a really important aspect of that, where in nature we see very high stock density in grazing herds that once kind of roamed the savanna. And then a long period before those same pastures were revisited by the stock on their annual migrations. So pasture utilization in those situations is high because there's a lot of competitive eating. There's only so much grass and there's a lot of mouths all lined up side by side, trying to get a belly full. Overgrazing is what happens when stock return to those plants before they have fully recovered. Overgrazing is not how short the pasture is grazed. It's about whether the plants have a chance to fully recover. So you can graze a plant really quite short and it will regrow, and it might regrow from some of its root reserves, but it will regrow and regrow fully so long as it's left alone to do that before it's grazed again. We've talked a lot about diversity, and what we're trying to do with this model of grazing is to increase diversity in the sward. And experience has shown that when we manage our pastures in this way, we have a natural accumulation of species, some of which that haven't been seen for years in these pastures, but the seed has been lying dormant in the soil waiting for an opportunity to emerge. And weed control is a really big part of this. And I gave a couple of webinars on weed control recently, and I used this slide, this picture rather, which is, which we have all seen, this kind of massive thistle in an otherwise productive landscape. And the question I ask here is, have we got too much weed or have we got not enough pasture? And I think that's a good question to ask, because here there is so little pasture. There's, we have opened the door and welcomed in the weeds. But if we have dominant, dense pasture that's grazed in the way that I've been talking about, we really limit the opportunities for weeds to come in. And when we manage pastures in that way, weeds just disappear. And what we're talking about doing with this is mulching the farm. And we all understand the importance of mulching garden beds and mulching, the vegetable garden, but we don't even think about it on our farm because, well, it's a completely nonsense and impractical idea. How do you mulch, hundreds or thousands of hectares? This is a way to mulch hundreds and thousands of hectares by working with nature and working with stock, with appropriately timed and strategic grazing to lay down the litter that we have grown under these plants, and that allowing that litter to function as a mulch while the plants regrow, and as a mulch to protect the surface of the soil, to protect soil function, to help the plants regrow. Now, I wanted to talk briefly about compost, and it's really important to say that composts ain't composts. The Australian standard for composts basically identifies three different types. One is called a pasteurized product, one is called a composted product, and the other is called a mature compost. And the three different types, if you like, are characterized primarily by the amount of time that they have been allowed to develop. So the pasteurized product is very young, very fresh product, where much of it has not developed into stable forms of carbon, into humus carbon. whereas a composted product or a mature compost have higher levels of stable carbon, higher levels of humus. You may sometimes hear people talking about humified compost. Well, what's humified compost? Humified compost is really just mature compost. It's compost that's been allowed to age so that much of the carbon is able to develop into a humus. And depending on what your problem is, so you might say, I think I need compost. Why do you need compost? Do you have a soil structural problem? Do you want to stimulate biological function? Do you want a fertilizer contribution from the compost? These questions will determine what kind of compost is most suitable for your situation. There's a lot of interest now in customizing compost. So if we're going to use compost, what else can we put in the compost to give us what we need? So for example, if we have a soil structural problem, then it's highly likely that the addition of gypsum or lime into the compost is going to greatly improve the response to that compost application, because not only are we putting in organic matter to help with the soil structure, we're also applying lots of calcium to help with that structure as well. So the consideration here as well, we might apply the lime and gypsum at the very end of the composting process so that its benefit is maximized. And the experience of adding lime in particular in composts shows us that we can get the same pH change from a lower application rate of lime. And this is to do with the earlier activation of the lime applied in this way by the soil life. And we can also add nutrients to compost. So if we're looking for a fertilizer contribution as well as a soil conditioning contribution from the compost, we can think about adding any kind of nutrients into the compost. We can think about putting in superphosphate, if that's what we want to use. We can put in urea, we can put in potassium fertilizers, we can put in trace elements, we can really put in anything we like. The only caveat there is, depending on what it is we want to add, some of these nutrients will be appropriate and beneficial to add them at the very start of the composting process. With others, it could be quite detrimental to do that, and they need to go in at the very end of the composting process. But certainly doing it this way saves spreading costs, and applying nutrients in an organic matrix is going to help with the stability of those nutrients and with their availability via those microbial agents. And the third question that we're beginning to explore more these days is how to apply the compost, where to apply the compost. So do we just put it out on the surface? Are we dealing with a grazing or cropping operation? Is it safe to use? Do we apply it to high standing biomass, low standing biomass? Do we work it into the soil, etc.? So as a general rule, compost is ideally always best worked into the topsoil. But in a grazing situation or a no-till cropping situation, that's not an option. So in grazing, we will look at grazing the pastures down hard and then applying the compost to maximize the likelihood of the compost soil contact at the very start, and then allow the pasture to grow up through that so that the compost the breakdown of the compost is facilitated by the more constant humidity and temperature that will be found at the base of a tall standing sward. Similarly with cropping, it can be just tickled into the surface of the soil at the same time as the plant is being, the paddock is being direct drilled. And subsoil manuring is about placing the material at depth to address subsoil constraint. And I mentioned the challenge of a sodic subsoil earlier, and subsoil manuring has been employed with great success to counter some of those hostile subsoils that have completely lost structure and function. There's a lot of interest these days in cover cropping and intercropping, and this is all about giving effect to what we've been talking about, getting more diversity in the sward and more diversity beneath the ground here. This slide also illustrates living roots year-round. So we've got between the plants, we've got dying off ryegrass, and we've got emerging chicories and lucerne to sustain grazing throughout the warmer months. So cover cropping can be part of paddock rehabilitation. It can promote year-round. It can be an alternative between cash crops or complement cash crops, but diversity is the key. And with intercropping, all of this is about increasing root architectures and deepening root systems and increasing diversity. And increasingly, we want to look at, say, incorporation of a legume underneath a cereal crop for both nitrogen fixation and to help with weed suppression. This is a really nice example from the United States of intercropping, a different form of intercropping, a kind of alley intercropping, or as the Americans call it, fence row farming, where we've got corn, soybean growing in rotation. So next year, everything basically shifts over one block. So where the corn is this year, I didn't do that. Where the corn is this year, the soybean will be next year, etc. And they're seeing substantial increases in average yields just by doing this. And the proximity of even two different crops like this increases opportunity for biocontrol by providing habitat for beneficial insects that may be preying on insects on the complementary crop. And these kind of systems are limited only by our imaginations. But if we understand that diversity is one of the principles of regenerating agricultural systems, we can, and in fact, Googling intercropping or cover cropping, you'll see, great examples of the myriad of ways that these principles are being applied. So integrating trees is another part of helping the system along. So, whether it's a cash crop in the form of farm forestry, or whether we're using trees to support alley planting, windbreaks, fodder trees, specialty crops, etc., and even to work with boutique livestock. And in fact, there's been a lot of interesting work done using salt push with sheep. Not that I'm really calling salt push a tree, but it's the same principle would apply where we're using something like salt bush as an alley planting to protect pasture land in between the alleys and to provide additional fodder and shelter. So in a summary, we're getting towards the end of our series, and hopefully some of these messages are beginning to coalesce. We're understanding that soil health is a product of balanced soil chemistry plus management practices. So, in today, we've really been talking about management practices and how by changing our focus on soil function, feeding the soil, getting the soil working with us is a really key element of soil health. I've seen some soils that are really nice, balanced chemistry, but it doesn't mean that they are functional, and it doesn't even mean that they're particularly stable or have good soil structure or anything like that. We want to focus on organic matter generation, the growing of organic matter and the return and cycling of that organic matter. But every farm is different, and every farm has the potential to sequester more organic carbon. I don't think that's too big a statement. I think there's few farms. I don't know of any farms that I can think of where I can say that farm has maxed out on the amount of organic matter that it is able to hold. So every farm has the potential to be better, and by better I mean healthier and more sustainably productive. So we really have, there's so much more that we can do to make our systems more resilient and more productive. And when we're talking about carbon and organic matter, we're talking about less stress, less risk, and more profit. And so in final summary, this is where we've come to date. And next week, I'm going to talk about bringing it all together, the monitoring and evaluation. So how do we know that we're having success? We'll talk a little bit more about soil and tissue testing next week, and there was a question came in during the week specifically about soil and tissue testing, which we'll cover in terms of chemistry, physics, and biology. And we'll also talk about the role of soil health cards, which are which have been developed as very simple on-farm tests that people can do that don't involve the expense of laboratory analysis, but it will yield really great information to allow you to know, are you making progress or not? Okay, back to you, Matthew.
Great, thank you very much, Declan. A lot to go through there. We've got some good questions to cover off. But those, I thought that was great. Those 5 principles of building soil carbon to completely in line with that approach to regenerating soils, like keep the soil covered, maintain living roots year round, minimize soil disturbance, integrate livestock, maximize crop diversity, and some great examples too that you pulled out under that. And I did like those 2 sort of categories in terms of fixing the problem and the drainage, deep ripping, soil keys, those examples there, as opposed contrasted with that approach in terms of helping. So fixing versus helping soils, grazing, how we do our grazing management, compost, intercropping, cover cropping, and also what you touched on too, that different mindset. And I thought that example too, in terms of, are we looking at a paddock with too much weeds, or are we looking at a paddock with not enough pasture, and just then how that might trigger off a whole bunch of management activity, all built around how we go about mimicking nature by design in terms of those management systems. So that kind of biomimicry with real consideration for those underlying system conditions, such as the brittleness of the Australian landscape. And in particular, I did like some of those concluding comments, and just to highlight one in particular, that every farm in Australia has the potential to build more soil organic carbon. So by no means have we tapped out or we lost any of that sort of opportunity to build more soil organic carbon. And ultimately, where does that lead to? Leads to less risk and more profit. So we'll jump into a few questions now, just in terms of going through. One of the aspects that you pulled upon was that role of nitrogen, overloading nitrogen, increasing microbial activity and decreasing soil organic carbon. So if there was a legacy load of nitrogen on farms, could that actually prevent increases in soil organic carbon? And then how would you assess if you had that legacy load, and then how might you address that legacy load of nitrogen on a farm?
Okay. Look, I'd probably say that in the first instance, legacy loads of nitrogen are probably less common than legacy loads of some other elements, such as phosphorus, for example. And part of the reason for that is the volatility of nitrogen. If there's a lot of excess nitrogen around in the form of nitrates and the like, it's very susceptible to leaching, as we've talked about. And in wet conditions, it's very susceptible to volatilization off. If nitrogen hangs around for long in the soil, it's going to be grabbed by the soil microbial community. Because nitrogen is so volatile, nature has really evolved many mechanisms to get it and get it fast. Because nitrogen is such a key element in protein synthesis, basically everything is after it. So you tend not to get too much free nitrogen if we have, it will reach an equilibrium reasonably quickly, either in the form of immobilized in microbial tissue or plant tissue, or in soil organic matter, or it will exit the system. We tend not to have too much free nitrogen floating around.
So then maybe just picking up on that theme in terms of other nutrients, are there similar interactions with phosphate fertilizers and then microbial soil carbon consumption, and that increases there are with the nitrogen? So do you have a similar microbial response at all?
Yeah, look, we're all fairly familiar, I think, with the concept of nitrogen drawdown, which is where we have a high carbon to nitrogen ratio. The soil microbes will they're more competitive for the available nitrogen in the system. So they'll immobilize it, they'll compete for it, they'll grab it ahead of the plant, and the plant will go yellow. So we'll say the plant is suffering from nitrogen drawdown. There's also a phenomenon of phosphorus drawdown for exactly the same reasons. If there's available nitrogen in the system, the soil microbes will always get it first. Now, we tend not to see phosphorus drawdown in the same way that we see nitrogen drawdown, but it can manifest in terms of just poor or slow plant performance or reduced productivity. And how that's usually counteracted then is with the application of some kind of phosphorus fertilizer. But if we understand that, it's very difficult to positively control or to direct control over soil function, over the microbes in the soil. So the work of Kuhnen et al. Was very much around saying, we need to make sure that we try and optimize nutrition really for the soil microbes, because if we provide them with the tools that they need, they will go to work and they will do what they do best, which is to organize their environment and work in conjunction with soils. Actually, the microbes would be quite happy if we all just went away and left them alone, and they'd get on with things very well, by themselves. So if anything, we need to think about managing the below ground herd. And in a healthy soil, we've got in general terms 2 tons of livestock below the ground per hectare, which kind of equates to the carrying capacity of a lot of our more fertile grazing land. So if we think we spend all this time and focus managing our beef herd or our sheep herd, we need to commit equal enthusiasm or dedication to managing the below ground herd as well. Now, Matthew, I think you've frozen, or I hope I haven't frozen. Okay, well, I'll answer another question just while Matthew is reconnecting, and I'm trusting that, that you're still with me. And there was a question that was asked about how do I apply compost to 190 hectares or 190 acres, sorry, of hilly country. And that's an expensive and challenging operation, because that will take a lot of compost over 190 acres. And if it's hilly country, the principal impediment may well be terrain and whether it's even possible to get a large vehicle up and down large hills. So in some situations like that, spreading compost might not be the most appropriate thing to do. I think in a situation like that, I would certainly be thinking, can I grow the carbon that I want in situ? And my focus therefore would be on regenerative grazing, in the way that we've talked about today and previously, to capture carbon in those systems. It's cheaper, probably longer term, but ultimately, just as effective and certainly sustainable. The other part of that question was about just related to the current concern that's been in the media about contaminated compost. The irony is that what those composts are contaminated with, the phenoxyacid herbicide residues, principally come from agriculture, because that's where most of those types of herbicides are used. They've got into the urban stream and have impacted lots of homegrown veggies and the like. There is a warning on a lot of phenoxyacid herbicides saying that they're incompatible with certain crops. It's always good for compost makers to be doing their due diligence, and this scare, I think, has alerted many of them to the risk that they're dealing with, and so there's a lot more testing going on at the moment to isolate those risks. As in general, though, concentrations of those residues are really very low. They've got low-ish half-lives of around 40 days in a compost. So I think the risk to general agricultural use is relatively low.
Declan, you're talking about rehydrating landscapes and sort of using that key line or natural sequencing. Is that applicable in all parts of Australian farmland? So for example, in Queensland with the sort of higher rainfalls?
Look, it's very much about keeping water on soil. So it's reversing that dehydration of landscapes. But I would say it's not applicable absolutely everywhere. So there would be a number of caveats that I would put on its use. Caveat number one would be if you have dispersive soils on sloping ground, you may end up doing more harm than good, because as I mentioned before, if we start ripping into these, with contour ploughing or trying to divert water and we go into dispersive soil, there's a high likelihood that we'll initiate tunneling in those landscapes, and that could be an absolute disaster. So we want to avoid that if possible. If we're in an environment where rainfall can be really heavy, it doesn't necessarily mean you wouldn't keyline your farm, but you would need to be really careful about when you do it, so that the land is really stabilized before, say, the wet season comes around. And also these things can be done, by degrees. So, the kind of lowest degree, I guess, of keyline planning would be just the use of contour banks to try and slow or arrest or direct surface water movement across a farm. So that's the kind of thing that probably requires, a bit really specific site assessment to determine the appropriateness of it and the safety of it. But certainly it should be used far, far more widely across so much of southeastern Australia than it currently is.
I guess reinforcing that point that every farm is different and it needs a level of customization in terms of the application of these principles and practices. Just coming up to the top of the hour, just a few more things to cover across, Declan. So do you see opportunities to design intercropping systems such that they could supply bulk of plant nutrition, so moving beyond just, say, legumes and soil organic nitrogen?
Sorry, so that they could do what?
So they could supply more plant nutrition beyond just, say, nitrogen drawdown.
Oh, look, absolutely. I mean, what we're trying to do with this approach is to free up nutrient cycling right across the board. This is not focused on nitrogen. It's not focused on phosphorus. It's really about saying we've got to get everything moving again. Got to get the system unstuck. So, yeah, it's certainly about broadening the availability of all nutrients.
And then there was a note from Teresa Chapman that UTAS is looking at legumes into dryland pastures with the soil kin strip tilling. So it'd be good to follow up from a dryland context and the importance of legumes in that species mix. Thanks, Teresa. A question on your fence row farm example, and how do they actually harvest the corn and the soybeans? So wouldn't the harvester been driving over one of the crops? A practical question.
Yeah, in that particular, because the soybeans were shown to wrap around the end of one of the end of the corn, I did the same question occurred to me. But the intention behind those systems is that they're laid out, like at header widths or multiples of header widths, so that harvesting and any kind of in-crop activity is set out in a way that can work as per normal and is not impacted by the neighbouring crop.
And now a question on sulfur deficiency and whether it can be viably fixed with sulfur to the soil, or whether it's best to continue supplementing livestock.
Yeah, look, sulfur is easily augmented, and elemental sulfur is a great thing to use. Bear in mind that elemental sulfur will have an acidifying effect on the soil. So if it's if your soils are acid, you may need to just keep an eye on that as well. But elemental sulfur is like 98% sulfur. It's a slow release form because it's a natural product. So you don't need very much of it because of its high concentration. So I'd be looking at using something like that. But sulfur is freely available in other elements as well. So if you were to use gypsum, for example, or potassium sulfate, there's high contributions of sulfur in those compounds as well.
Great, thanks, Declan. Well, we're at the end of webinar 6. This was management practices and how to build a soil carbon. Thanks to our team at AgriProve and to Mel for pulling all the background of the webinar together. Thanks to the presenter, Declan McDonald from Regen Soils. As Declan said, next week's topic, or the next webinar's topic, is about bringing all of this together and looking at how we monitor and evaluate on farm. And then speaking of evaluation, we'll also be sending out just an email seeking your feedback on the content that we've covered through this webinar series. And more importantly, what suggestions that you might have in terms of additional resources that you would like and find useful that we could develop in the future in terms of assisting in that transition to growing healthier top soils. So look out for that. Anything during the week, feel free to email us at team@agriprove.io. Once again, thank you for your attention. We look forward to catching you up at the next and final episode. And that's a bye for now. Thank you.
Thank you.